Hello everyone. On this video we will be looking at linear definitions. Okay. So if you have a non-vertical function written in the form f of x equals mx plus b, that is called a linear function, where your m is your slope and the point 0b is your y-intercept. Okay. So if you have a function that's in any form other than this one, that would be called a nonlinear function. Okay, so nonlinear could be quadratic, it could be cubic, it could be a number of other options. Okay, so if you have that function, that linear function f of x equals mx plus b, if your slope is positive, or if m is greater than 0, your slope is positive. That means your graph is going to go up and to the right. If m is less than 0, your slope is negative, which means your graph will go down and to the right. And if your slope is equal to 0, or your m is equal to 0, then the slope is neither increasing or decreasing. It's just horizontal in both directions. All right. So if you are still writing this down, feel free to pause it and finish up. But we're going to go ahead and move on to the next page. Okay, and that, if you remember, the definition of a slope, which is y2 minus y1 over x2 minus x1, but in function notation. Oh, let me see if I can clear this up a little bit. All right, so in function notation, that's f of x2 minus f of x1 over x2 minus x1, where x1, f of x1, and x2 and f of x2 are points on the line. Okay, so when you're using function notation, this will be your slope, which is basically the same thing as the slope from this formula here. Okay. Now notice also that this is the formula for the average rate of change. So if they ask for the average rate of change, it's the same as the slope. All right. So if you are still writing, feel free to press pause. But we're going to go ahead and move on to a couple of examples. Okay. So let's say, for example, you have two functions. You have f of x equals negative 2 over 3x plus 4. And you have g of x equals negative 2. And h of x equals 5x minus 4. Brush that off. There we go. Okay. So let's say for A, we want to find the slope and y-intercept for each of them. For B, we want to use the slope and intercept to graph the function. Okay, so we're not going to plot points. We're just going to use the slope and the intercept to graph it. For C, we want to find out what the average rate of change is for each function. And for D, we want to determine if the function is increasing, decreasing, or constant. Okay. So let's start off with our f of x. So f of x equals negative 2 over 3x plus 4. Okay. So for A, we know that since it's in the form, I'll write a little form underneath it. F of x equals mx plus b. We know that your slope is m equals negative 2/3. And we know your y-intercept is 0, 4. Okay. Remember, your y-intercept is 0b. But in this case, it's 0, 4. Okay. Now for B, we want to know, use the slope and intercept to graph the function. Okay, so let's say we have our graph here. Okay, let's say we have 1, 2, 3, 4, 5, 6. We'll go to 6, and let's say we have 1, 2, 3, and 4. Yep, sorry about that. Got to look up and make sure you could see it. There we go. Okay. So we know that our y-intercept is 0, 4. So 0, 4 is right there. Okay. Now using the slope, remember we have a negative slope, so we know it's going to be decreasing. So remember your slope, which is negative 2 over 3, is also your rise over your run. Okay, so if we start here at this point, at our y-intercept, we go down 2 to the right 3. Okay, so we go down 2 and to the right 3. So we have another point on the line. So if you want, you can go from that point, you can go down 2 and over 3. Okay, and then you can just connect those 3 points where hopefully my hand-drawn graph will be okay. Yep, there you go. Okay, so that's the graph of f of x equals negative 2 over 3x plus 4. Okay, so that's your 0, 4, and this point here is your 6, 0. And actually, if you find your x-intercept, you'll find that's your point there. Okay, so you can either do the rise over run, or you can find the x-intercept. Okay, so for C, we know that the average rate of change for a linear function is equal to f of x2 minus f of x1 over x2 minus x1. Okay. But we also know that this is the slope formula. Okay. So if we want to find out the average rate of change, and we already know the slope, then we know that the average rate of change is just equal to the slope. So the average rate of change is equal to negative 2 over 3. Okay, so now if you actually wanted to calculate it, you could. You could do the same thing. So let's say if we pick those 2 points on the graph. Okay, so let's say for the points 0, 4 and 6, 0. Remember, this is your x1, f of x1, and x2, f of x2. Okay, so if we plug it in, f of x2 is 0 minus 4, so 0 minus 4 over 6 minus 0. Okay, which is just negative 4 over 6, but if we simplify it, it's negative 2 over 3. Okay, so if you didn't know your slope, you could always figure out your average rate of change and you get the same thing. But if you already know your slope, you know the average rate of change of a linear function. All right. Okay, so let's go ahead and finish this up. We should have enough room for D, even though we're reaching the end of the page. I'll draw a little line to separate it. Okay. So, how do we know if it's increasing, decreasing, or constant? Just look at the slope. Since the slope is equal to negative 2/3, or in other words, the slope is less than 0, the function is decreasing. All right, so we're done with that one, f of x. We've solved everything for f of x. Okay, so if you're still writing this, feel free to press pause, but we're going to continue on the next page. You can kind of see the image of the next page going through. Let me see if I get another sheet of paper so you won't be distracted by what's after that. Okay, there we go. That's better. Okay, so for g of x equals -2. Okay, so for a, you're going to rewrite it as g of x equals 0x. 0 times x, minus 2. Okay, because remember, now it's in the form g of x equals mx plus b. Okay, so we see that our slope is equal to 0, and our y-intercept is 0, -2. Remember, your y-intercept is the point 0, b. Okay, now for b, we want to use the slope and y-intercept to graph the function. This one will be pretty easy. Okay, so if we, let's say you have your y, you have your x. Let's say this is our -2. Okay, so if we go to the point 0, -2, which is right here, whenever your slope is 0 and your g of x is just a constant, it's a horizontal line through that constant. Okay, so for c, remember your average rate of change, you already know your slope. Which in this case is 0. That's your average rate of change. Okay, it's not increasing, it's not decreasing, it's just constant. Okay, and for d, you want to know whether or not it's decreasing, increasing, or constant. We see that since the slope is equal to 0, the function is constant. Okay, now let's look at h of x equals 5x minus 4. Okay, so we see here for a, the slope is equal to 5. And the y-intercept is 0, -4. Okay, which is your 0b. Okay, so if we wanted to graph this for b, okay, so we know, we put that graph here, make sure I have enough space. That's your x and that's your y. So let's say we go down -1, -2, -3, -4. 1, 2, 3, 4, 5, 6. And let's say 1, 2, 3, 4, 5. Yep, sorry about that. Have to remember to make sure it's high enough for you to see it. Okay, so we start at our y-intercept, which is 0, -4. So 0, -4 is right there. Since our slope is 5, we can just make that 5 over 1, which is our rise over run. Okay, so we go up 5 to the right 1. Okay, so from this point, we go up 5, 2, 3, 4, 5, and to the right 1. And from that point, we go up 5 and to the right 1. And we can keep doing that forever. Up 5 to the right 1, up 5 to the right 1. But those 3 should be more than enough for an adequate looking graph. All right, so let's go ahead and finish up C. So we know for C, we want to find the average rate of change. And the average rate of change, if you know your slope, is just your slope. And again, if you didn't know your slope, you could always plug in 2 points on the graph and find your average rate of change. Okay. And for D, we can tell just by looking at the graph that it's increasing. But if we didn't have the graph here, just the fact that our slope is positive. So since the slope is equal to 5, or it's just greater than 0, we know the function is increasing. All right. So if you are still writing, of course, feel free to press pause and finish up. But we're going to go ahead and move on to our next example. Okay, so I can go ahead and move this paper here. I'll put it behind this one so you're not looking at the next problem again. There we go. We can focus on this one. Okay, so we want to determine if the function tables are linear, nonlinear, or nonlinear. If they're linear, you want to find the slope. Okay, so from x equals -2, we have 1/4. For x equals -1, we have 1/2. X equals 0, we have 1. X equals 1, we have 2. And x equals 2, we have 4. So x equals -2, we have -4. X equals -1, we have 0. X equals 0, we have 4. X equals 1, we have 8. And x equals 2, we have 12. Okay, so honestly, you could look at both of them and find out whether or not they're linear or nonlinear. I'll show you the steps, but then I'll show you how to just eyeball it. Okay, so for A, let's say we pick the point -2 and 1/4 and -1, 1/2. And we find the slope. Okay, so remember the slope is equal to f of x1 minus f of x2 all over x1 minus x2. Okay, so if we plug this in, that's going to be x1 f of x1 and x2 f of x2. Okay, so our slope is going to be f of x2 minus f of x1, so 1/2 minus 1/4 all over -1 minus -2. Okay, so if we multiply this by 2 over 2, we have 2 over 4 minus 1 over 4 all over 1. So 2 minus 1 is just 1, so we have 1/4 over 1, or just 1/4. Okay, so between these 2 points, your slope is equal to 1/4. Okay, now let's look at 2 different points. Let's say from 0, 1 to 1, 2. So from slope from 0, 1 to 1, 2, where this is your x1, f of x1, and x2, f of x2. Let me move that up a little bit. We know that your slope is going to equal f of x2 minus f of x1, 2 minus 1 over 1 minus 0. 2 minus 1 is 1. 1 minus 0 is 1, or your slope is just 1. Okay. Sorry about that. I have to keep remembering to push that up. I get so wrapped up in the math, I forget to push it up. Okay. So you have 0, 1, and 1, 2. Once you plug those in and get a slope of 1, now you see here that on the very same linear function, you can't have, if it's linear, you can't have two different slopes. Okay. So the slopes have to be consistent throughout. So it's nonlinear. Okay, so let's look at B. Okay. So for B, you have the same thing. You want to look and you want to see if they all have the same slope. Okay, so you want the same slope from this point to this point, the same slope from this point to this point, the same slope from here to here, and the same slope from here to here. Okay, so we're just going to pick a couple of points. Let's say from -2, -4 to -1, 0. And our slope is going to equal f of x2 minus f of x1. So 0 minus -4 over x2 minus x1, -1 minus -2. Okay, so this ends up just being 4 over 1, or just 4. Okay, so from here to here, we know your slope is equal to 4. Okay, so what if we go from -1, 0 to 0, 4? From -1, 0 to 0, 4, f of x2 minus f of x1, so 4 minus 0 over 0 minus -1. That gives you 4 over 1, which is again 4. Okay, so you're going to get the same thing if you go from here to here, and the same thing if you go from here to here. The slope will be 4 for all of them. Okay. Now, the quickest way you can tell is the fact that if your x values are increasing by 1, you should have the same distance between each y value. So here, you have a distance of 1/4. But from here to here, you have a distance of 1/2. But from here to here, you have a distance of 1. From here to here, you have a distance of 2. So it's not the same slope. The distance between your y values should all be the same if your x values are increasing by 1. Okay, so you see here, from negative to all increasing by 1, but your y values from -4 to 0 went up by 4. From 0 to 4, it went up by 4. From 4 to 8, it went up by 4. From 8 to 12, it went up by 4. So your slope is 4 throughout all of B. So your slope is equal to 4. Well, it's linear, we know that. And your slope is equal to 4. All right. So if you are still writing this, feel free to pause it and finish up. But we're going to go ahead and move on to our last set of examples. Okay, so let me move that out the way since we're on our last page. Okay, so for f of x equals 3x plus 5 and g of x is equal to -2x plus 15, We want to solve f of x equals 0, solve f of x is less than 0, solve f of x equals g of x, solve f of x is greater than or equal to g of x, and then we want to graph f of x and g of x and plot where f of x is equal to g of x. Okay, so let's get started. Okay, so for A, find f of x equals 0, since that's our f of x, that just means we want to find where 3x plus 5 is equal to 0. Okay, so if we subtract 5 from both sides, we get 3x equals negative 5. We divide both sides by 3, we get x equals negative 5 over 3. Okay, so if we plug in negative 5 over 3, that f of x will equal 0. Okay, so for B, we want to find where f of x is less than 0. It's the exact same process as up here. So if you want to use this, you can, but we're just going to redo it for practice. So we have 3x plus 5 is less than 0. Again, subtract 5 from both sides. We have 3x is less than negative 5. Divide both sides by 3. About to write 3x for some reason. We have x is less than negative 5 over 3. Okay, which means our solution interval is from negative infinity to negative 5 over 3. Okay, and again, if you want to write out a number line, we have negative 5 over 3. That entire interval here is the solution. Everything to the left. Okay, so now let's solve C. Go ahead and write and make that 3 a little clearer. There we go. Okay, so for C, we want to solve where f of x equals g of x. Okay, so since f of x is 3x plus 5 and g of x is negative 2x plus 15, that just means we want to solve where 3x plus 5 equals negative 2x plus 15. So if we add 2x to both sides, we get 5x plus 5 equals 15. If we subtract 5 from both sides, I'm going to go ahead and just move that down here, we get 5x equals 15 minus 5, which is 10. So if we divide both sides by 5, we get x equals 2. Okay, so that's where f of x equals g of x. Okay, now for D, we do the exact same thing we did for C. F of x is greater than or equal to g of x. Okay, so that means 3x plus 5 is greater than or equal to negative 2x plus 15. Okay, and again, we could use this if we wanted to, but we're just going to practice doing this. Add 5x to both sides, add 2x to both sides. Get 5x plus 5 is greater than or equal to 15. Subtract 5 from both sides. We have 5x is greater than or equal to 10. Divide both sides by 5. We get x is greater than or equal to 2. Okay, which means our solution interval is x is greater than or equal to 2. Since we're greater than or equal to, we're going to use the bracket. So we'll go from 2 all the way to infinity. Okay, and again, if you wanted to visualize it on the number line, you just have 2. X is greater than or equal to 2. So it's greater than or equal to 2. So it's everything from 2 to infinity. We have infinity, and we have our negative infinity. So if you wanted to look at it on the number line, that's how it would look. Okay. Now let's go ahead and plot E. We should have enough room to finish this on this page. Move it up just a little more. There we go. Okay, so let's say our graph is right here. Okay, well, this is our x-axis and this is our y-axis. Okay, so let's say for let's say f of x is 3x plus 5. Now we could do the rise over run, but we're just going to go ahead and plot points. Okay, so let's say x is equal to 1. 3 times 1 is 3 plus 5 is 8. Let's say we make x equal 2. 3 times 2 is 6 plus 5 is 11. Okay, so let's say we also want to graph our g of x. That's g of x equals negative 2x plus 15. Let's say we make x equal 1. Negative 2 times 1 is negative 2. And negative 2 plus 15 is 13. And let's say we make x equals 2. Negative 2 times 2 is negative 4. Negative 4 plus 15 is 11. Notice that. Okay, because remember, they're equal at x equal 2. That means that should be the point where they cross each other. Okay, so let's say 1, 2, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So let's say that's our 13 up here. Then you can make the graph bigger if you like. Okay, so for f of x equals 3x plus 15, we have the point 1, 8. So when x equals 1, y equals 1, 2, 3, 4, 5, 6, 7, 8. And when x equals 2, y equals 11. So 1, 2, 3, 4, 5, 6, 7, 8, 10, 11. So it should be right about there. Okay, so we know this is roughly how our f of x will look, which is 3x plus 5. So I just wrote f of x here. Now for our g of x, when x equals 1, y equals 13. So we have 1 and 13, which is right there. And when x equals 2, y equals 11. So we have 2, 11, which is right there. So when we graph it, it should look something like that, where this one is our g of x. Okay. So again, just from up here, we knew that if we plugged in 2 for f of x and 2 for g of x, that it would give us the same y value, which is 11. Okay. So we know that they cross at the point 2, 11. All right. So hopefully this made sense, and I will see you on the next video.